In this video, we'll walk through the solution to the example problem of nuclear decay equations for gold, and hopefully you've had an opportunity to work through this yourself already. So I'm going to go through these one at a time, and I'm going to start with gold 169 right here. It's going to undergo alpha decay. So looking at this, I can do a few things right off the bat. I need to remember what alpha decay is. That's going to emit a particle that has 2 protons and 2 neutrons, or the helium nucleus. And I can write it like this as a helium nucleus, or I can write it with the alpha symbol as well, as long as I'm including the mass and the atomic number. Now, gold 169 can be written in its chemical isotope format. And if I look at the periodic table, gold has an atomic number of 79, and I'm given this mass number of 169. So I'll write out my chemical decay equation. So gold 169, an atomic number of 79 is my starting point. It's the original isotope. It's going to decay, so I'm only writing the gold 169 on the left-hand side. Then I write an arrow. Now I'm going to write out my alpha particle because I know that's what's being emitted, and I'm told that in the problem. Now I need to just figure out what is it that will be left over after that helium particle is ejected. So I am going to figure out my mass number first. It'll be 169 minus 4. That way, when I add my helium particle and my new nucleus together, I'll get this 169. So that's going to equal 165. So that'll be the mass number of my new isotope. Now I'll figure out my atomic number. I've got 79 that I need the entire right-hand side to equal. That minus 2 will give me the atomic number of my new isotope. So that's going to be 77. Now, I look to the periodic table and I try to find, well, what has an atomic number of 77? And it's iridium. So this iridium 165 is my new isotope. So the elements of a correct nuclear decay equation would have this iridium 165, my helium emitted particle, my arrow, and my original nucleus on the left-hand side. Let's take a look now at gold 180 and its positron decay. And for this one, you got to remember what positron is. Now, positron is like an electron, so it has very little mass, but it has a positive 1 charge. You could also write this as beta 0 plus 1. My gold 180 needs to be written in its atomic symbol as well. My mass number is 180, and I've already figured out that 79 is the atomic number of gold. So now I'm ready to start. I'm going to put my gold chemical symbol, isotope symbol, on the left-hand side of my arrow. Then I'm going to put my emitted particle, because I already know that part. And then I'm going to try to figure out what my new isotope is. I'm going to take the mass number of my starting gold and subtract the mass number of my emitted particle. It's going to give me 180 again. Then I'll take the atomic number of my original isotope, subtract the atomic number of my emitted particle. That's going to equal 78. Then I use that atomic number to figure out what the element is. I look to the periodic table, and 78 is listed as platinum. So my gold 180 will decay by positron decay to platinum 180. All right, let's take a look at gold 201 and beta decay. So let's remember what beta decay is. That is our electron. So it has a -1 atomic mass. I could also write this with the beta symbol as well. And the important part is this 0 and -1 mass and atomic number. My gold 201 can be written in its atomic symbol as gold with 201 in the upper left hand. And my atomic number is still 79 because it's still gold that we're talking about. So 201 for the mass number and 79 for my atomic number and AU for my chemical symbol will be my isotope symbol for gold 1 or 201. That's my starting point, and so I'll draw an arrow, and then the particle that's emitted is a beta particle, so I'll write that next. And now I'm going to figure out what is left over after that beta particle is emitted. So I'll take my mass number and subtract the mass number of my emitted particle, and it'll still be 201. Then I'm going to take my atomic number, my starting point, and subtract the mass number of my emitted particle. And be careful here because we have minus a negative. So this is actually +1 overall. So it's going to equal 80. And when I look to the periodic table to figure out what element has an atomic number of 80, it is mercury.